Let us switch gears and do naming of covalent compounds. How to name a covalent molecule. Example 1. Name each covalent molecule. The first one is going to be NO2. The second one is N2O4. How would you name covalent molecule? Now, the first thing I want you to realize the characteristic, or remember the characteristic of covalent molecules. Characteristic number 1, they are made from non-metal plus non-metal combining. Number 2, there's gonna be a sharing of electrons. Ionic compounds were made by transfer of electrons, complete transfer of electrons. Now, if you look at NO2, we do have oxygen and nitrogen. Both of them are non-metals. So I expect that this is a covalent molecule. Now, if it's covalent, then there's a system of naming covalent molecules, which is different from naming ionic molecules. So still here I have a nitrogen and I have an oxygen. So these two is a compound. Now look at them. Both of them are type of nitrogen oxides. They have a nitrogen and an oxide. So we really have to differentiate them even better, not just to call this nitrogen oxide and this nitrogen oxide. That's not correct. Now, the oxide comes from oxygen because it's the anion. We call it oxide, just like if the second element was chlorine, we'll call it chloride. So now, how do we really define their names rather than just calling them, both of them, types of nitrogen oxides? So we go to step 2. We would add a prefix to show the number of each atom of element in our covalent compound. Mono is usually not used. It's omitted when only one atom of the first element is present, but it is retained for the second element. So if the second element is just one, then we'll have to say it. For example, if you have CO as a molecule, yes, you call this carbon, not carbon oxide, but we'll have to say carbon monoxide. Rather than calling it monocarbon, there's one carbon, one oxygen, rather than calling it monocarbon, monooxide. No, that is redundant. So the correct name will be carbon monoxide. You omit the mono for the first element, the carbon, but you emphasize it, you mention it for the second element, the oxygen, to be carbon monoxide. Similar with NO, it's not mononitro, you call it nitrogen monoxide. Okay, you don't say mononitrogen monoxide. No, it's just nitrogen monoxide. That's what that's really saying. The prefix mono is usually omitted when only one atom of the first element is present, but it is retained for the second element, monoxide, carbon monoxide, for example. Okay, if the combination would place two vowels next to each other, omit the first vowel. So remember what I said up there. I said monoxide because we have mono and oxide. So we are going to omit the first vowel and then combine the N to the O to give us monoxide. So not monoxide. That's the idea there. Naming covalent compounds continued. So again, if you have one element you're trying to list, say mono, 2 elements of the same di, 3 will be tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 9 nona, and then 10 is deca. Now, finally, we can differentiate our two molecules, NO2 versus N2O4. I have one nitrogen, just say nitrogen, and then I have 2 oxygen, so we use di as an infix, dioxide. Okay, remember oxygen appearing as an anion, it's gonna be oxide. Here you have 2 of the first element, so it's dinitrogen, and 4 of the second element, tetroxide. So you know we should have said tetraoxide, but you have 2 vowels, a, e, I, o, u. So we omit the a and we go with the o, tetroxide. Okay, which is what this rule right here was telling us. Let us do more examples. Provide the names to the following covalent compounds. So again, the title for this exercise is naming covalent compounds. What's a compound? A structure made of 2 different elements. Why is it covalent? Because it's between a nonmetal, is a combination or composed of nonmetal and nonmetal joined by sharing electrons. So the first one I would like you to name is this one. Both phosphorus and chlorine are nonmetals. I see I only have one phosphorus. There's an implied one as a subscript of the P. So we don't say monophosphorus. We're just gonna call it phosphorus. And then I see I have 3 Cls. It's a chlorine. When chlorine is an anion, a Cl minus, it becomes a chloride, but there's 3 of them, so trichloride. That takes care of that. Number 2, you can do N2H4. This one, I see I have 2 nitrogens, so it's gonna be dinitrogen. And then I see I have 4 hydrogens. Hydrogen as a second atom becomes hydride. There are 4 H's there, so it's dinitrogen. 4, it's tetra. When hydrogen is an anion or the second element becomes hydride, so dinitrogen tetrahydride. Okay, so let's go to the next one. Let's do the common molecule H2O. This one we usually call it water, but it should be dihydrogen. So hydrogen is the first element, so we write it in full. We don't say dihydride. It's the first one, so hydrogen. Dihydrogen, and then there's 1 oxygen, so it will be monoxide. We drop the first O because there's 2 vowels combined. You don't want to say monooxide. No, you drop the first O, so it becomes monoxide. So what is dihydrogen monoxide? Number 4, let's do CO2. Yeah, CO2 is plainly called carbon. There's 2 oxygens, becomes oxide, carbon dioxide. And then of course if you have CO, there's only 1 carbon. You don't say monocarbon, you say carbon monoxide. Mono is used for the second element. And then we keep going. Let's say you have number 6, a molecule that has the formula N2O. This one would be dinitrogen. 1 oxygen, there's 1 oxygen, so monoxide. Okay, if you had it as, I'm trying to think of other formulas. Let's say you had PF5. That one would be phosphorus, pentafluoride, penta standing for 5. And then we keep going. Number 8, let's say someone gave you a structure with PCl6. That one would be phosphorus. 6 is hexa, not hexachlorine but hexachloride. So that is the idea and examples of naming these guys.